Hello, this lecture is about energy and its forms. So our objectives for this lesson are to be able to define energy as it is used in physics. So what is energy? What do we mean by this term? When we say energy, what do we mean? Identify different forms of energy. Provide justified examples of objects with various forms of energy. So justified examples means you should be able to provide an example and explain why. In the justification, why does it have that form of energy? How do you know? Which is an important question. So let's talk about energy. Energy is a very difficult thing to define. It's actually very hard even for scientists to define exactly what energy is. In physics, we're going to define it a particular way, and that is the stored ability to cause change. If you're able to cause change, you have some sort of energy. And we're going to link these two ideas together very closely, change and energy. I'm going to make two statements that are going to be true for the scope of this class. Whenever a change occurs, energy must be transferred. Let's think about an example. When I push a chair, a change is occurring. The chair is getting pushed off to the side. I had to transfer energy to that chair. I had to push it. Energy went from me to the chair. So there's a change that happened there, a physical change that we could observe, and energy had to be transferred for that to happen. And the opposite is also true. The converse is also true. Whenever energy is transferred, a change must occur. If I move energy from place to place, even if we can't see it, some kind of change happened. Okay? It could be on the atomic level, it could be molecules rearranging themselves, it could be a gas going to higher pressure or lower pressure. Something had to happen whenever energy is transferred. A change will happen. Okay? So everything in science has a unit. When we're starting to describe how we measure things, we measure energy in a unit called the joule. And Joule was a scientist, and he did a lot of work in energy, and so we named the unit of energy after him. So you might say, how much energy is in my cup of coffee? And I might say 130 joules, or whatever the number is. Okay, so we measure energy in joules. So some examples of energy. Objects on a hill. If I have an object on a hill, here's my hill, and I've got a boulder at the bottom of the hill, and I've got a boulder up here at the top of the hill. And my question would be, which one of these objects, let's call this one A, and we'll call this one B, which one has more energy? And I think the answer most people would say is A, that this object has more energy. And the reason why is that it has more ability to cause change when it's up here. A boulder that's high up could roll down the hill, it could fall and push things out of the way. It can cause a lot more change when it's up here. It has the potential to cause a lot more change when it's up here than when it's down here. So we would say that this object has more energy than this object because of its height. We'll have a name for that a little bit later on. Another example of energy might be objects in motion. Objects in motion can cause change as well. So let's say that I have a car and it's standing still, it's not moving at all, and then I also have another car, and this particular car is moving very quickly. And I'll just put an arrow here to say that it's moving. So which one of these cars is going to have more energy? I've got a big arrow here. And I'm going to say that the car with more energy, from this perspective, is the car that's moving. Why does it have more energy? It has more ability to cause change. A car that's moving can run into other things. It can push air aside. It can cause a lot of change. A car that is standing still maybe could still cause some change if you zoom way, way, way in or look at it from some other perspective. But in general, for most purposes, this car up here that's standing still is not going to be able to cause as much change as this car down here that's moving. This car that's in motion has more energy than the car that is stopped. And a final example, stretched objects. Objects which are stretched or compressed, I'm going to put compressed objects, can have energy as well, for the same reason that they can cause change. If I take a spring, for example, and I stretch it out, now this spring is going to want to pull inward. It wants to pull stuff towards itself, and that is going to cause some change. It could pull an object over. A compressed spring is also storing energy. If you squeeze that spring, it really wants to pop back out and loosen itself, and that is some energy as well. You could use that in a spring-loaded cannon, for example, to shoot some sort of object or catapult some sort of object away. You can use it to hold a door shut. You can use it for all sorts of purposes. So both of these objects have energy stored in them because, same reason, they have the stored ability to cause change. Okay? So let's talk about a few different forms of energy. The first form I'm going to talk about is mechanical energy. Mechanical, it sounds kind of like the word machine. And there's a reason for that, because mechanical energy is the energy of physical objects. If it's a thing that we can push or pull or set in motion or change its direction or pick up or throw, anything like that, we're going to talk about it in terms of its mechanical energy. And it comes in three types. The first kind is called gravitational potential energy. In middle school, you probably saw this as just potential energy, PE. We're going to be very specific here at our current level and call it gravitational potential energy, because there are many different kinds of potential energy, and I'm going to show you another one in just a minute. But gravitational potential energy is energy that is stored in an object's height. So the higher up something is in a gravitational field, the more gravitational potential energy it's going to have. And if we look back at our examples over here, I was talking about two objects on a hill, and I said that object A has more energy than object B because it has more potential to cause change. What kind of energy does it have? It has GPE, gravitational potential energy. This object up here has more GPE than object B. Okay. Another form of energy which you may be familiar with is called kinetic energy, or KE. And kinetic just means motion, or things that are moving. And this is energy that is stored in an object's motion. That's the key word, motion. And if we look back at our objects in motion over here, these two cars, we said that this car that is moving has more ability to cause change. It has more energy than this car up here. And this car has more KE, or kinetic energy. Okay? And the other kind of mechanical energy that we're going to talk about in this class is elastic potential energy. Note that it is also a potential energy. It has sort of a stored potential to cause change. But this is different. It is elastic. And if you think about things that are elastic, they stretch, and that is energy that is stored in a material that is stretched or squeezed. So we're talking about elastic, rubber bands, could be springs, even a lot of materials. Most materials are going to flex in some sense. So both of these objects have EPE. They have elastic potential energy because they are either stretched or compressed. Okay, and they want to return back to their normal position, and that is a stored ability to cause change. It is energy. Okay, so that's mechanical energy. I'm not going to go into too much depth about these other forms of energy, but you do need to know what they are at a very basic level right now, just to be able to identify them. And for certain forms of energy on this list, we're going to go into a little bit more depth later on in the year. The first of these other forms of energy is called thermal energy. Thermal reminds me of heat, of warmth, and it is exactly that. It's energy stored in the random motion of molecules. And we're going to study what temperature is and what heat is a little bit later on in the year. But if you just associate it with things that are warm, cold, heat or thermal energy moving from place to place, anything to do with temperature is thermal energy. We also have electrical energy. We use this a lot in our daily lives. It's the energy of charged particles inside of an atom, and if we zoom way in, we're going to see negative charges and positive charges moving around, and the movement of these charged particles is going to cause what we call electricity or electrical current. And this moves energy around. This is the kind of energy that powers our cell phones, our lights. Anything that runs on electricity is going to be using electrical energy. And we'll learn a little bit more about that this year as well. Radiant energy, I'm going to define as energy traveling by electromagnetic waves. The big key word for now is going to be light. If you have light coming to us from the sun, it is through radiant energy. It travels through space about 93 million miles and gets to us here on Earth through electromagnetic waves, through light waves, and many other electromagnetic waves as well. There's energy in radio waves. There's energy in microwaves, or you wouldn't be able to cook your food with a microwave oven. There's energy in X-rays, and we'll learn about these a little bit later this year as well. But key idea, if it's traveling by electromagnetic waves or some form of light or invisible rays, it's going to be radiant energy. Chemical energy, very important. It's energy stored in chemical bonds. And well, what are chemical bonds? We can go into a little bit more detail later, but for now that means food. The food that we break down when we eat is giving us, as animals, chemical energy. Fuels, anything like gasoline, natural gas, anything that we burn is going to be chemical energy. There's energy stored in those chemical bonds in the gasoline, and when we burn it, we release it and turn it into thermal energy, for one, and we use that energy in those other forms. Batteries are something we don't really think about too much about what's inside, but if you opened up a battery, you would find a lot of chemicals inside, acids, and certain metals that move these charged particles from one place to another. That is stored chemical energy. So when we use a battery in, say, a circuit later on this year, we're going to talk about it in terms of its chemical energy. Okay? Food, fuels, batteries, chemical energy. And the last one on my list here is nuclear energy. We will not be talking about this one in too much depth at all this year, but it is energy stored in the nuclei of atoms. In the very center of each atom is a nucleus, and we can either slam those things together. We can slam two atomic nuclei together and get a lot of energy out of it. That's called nuclear fusion. Or we can break those nuclei apart, and that also releases a lot of energy. Not as much as fusion, but it does release a lot of energy. And we call that fission when they break apart. So breaking apart, slamming together. And those we're going to call nuclear energy. Okay. These are the various forms of energy. And in your notebook, I would like you to write these questions down and answer them. What is energy? What does it mean for one object to have more energy than another object? How do we measure energy? What do you think a joule of energy physically represents? And describe and justify one real-world example of each form of energy. So I'm asking you to go back to these three forms of mechanical energy, and as well as the other forms of energy that we listed right here. For each one of these, can you come up with a specific real-world example and tell me why? Why is it that form of energy? How do you know that your example of thermal energy is about thermal energy. And, as with all good Cornell notes, I would like you to write a summary at the bottom, 2-3 sentences of what you learned. Go back to our objectives. Can you define energy as it's used in physics? Can you identify different forms of energy? And can you provide justified examples of objects with the various forms of energy? If you can't, listen to this video again or check out some other resources on the web. Ask your peers, ask your teacher, and you should be able to get a little bit further. Thanks for watching.